Okay. So, in this segment what we will take up is the case of reflection of these waves, pressure waves, velocity waves, when it meets a particular interface. Okay. Because if you remember, we are moving towards that end condition of pipe. So, this is one step towards that. To simplify the system, what we have done is here it is not very different from that. Only thing what we are saying is wave is coming from this side where there is a fluid of rho 1 and C1 property, okay, and on this side there is another fluid, okay. So, if you wish, you can think that infinite tube which you were thinking up to infinite by 2, it was rho 1 by C, and at infinite by 2 after that it is rho 2 C2. Okay. Now, if that is the condition, then what happens to the wave which was coming from this side? Now, we saw that whether it is the tube or the plane waves basically are coming from this side. Say I will call that as Pi for incident, and that I will write as say A1 e raised to j omega t minus kx. I will change one thing, saying that it is k1, like that. Now, should I use A1 to be complex or real? Think about it. I will use it as a real number because I am starting my discussion from there, saying that some wave is getting incident. So, that is like an input for me. Then something will happen to this wave, it will be reflected back, something will be transmitted. So, now for them I cannot assume that this coefficient or amplitude is real number, but for the input one I can always tell that, because I am free to do that, because I will tell everything else in terms of this. So, why to put a phase here, right? I have been saying this almost for the 5th time now, and then I will tell this I think for another 3-4 times in this course. Anyways, so this is a real number. I mean, you can take a complex with a known phase, or that phase can be taken 0 and it is a real number. And then what happens is, as I was saying, something will be reflected back. I will call that say PR, and to be consistent I can put a complex thing here, a tilde, and then some wave is transmitted, it is P transmitted. Okay. Again this with a tilde, saying that it is a complex variable. Here I am writing this because this is anyway complex. So, P is a complex number, but the coefficient or the amplitude need not be complex. Now, this one you can write as what I have written here, say B1. This 1 actually is telling us that we are on the region 1. This is region 1, this is region 2, and B1 is telling me that it is a reflected wave, and e raised to j omega t plus k1x, right? And here I am using k1 and k1 to tell that there will be different k on that side. Now here I will put a tilde over b1 to remind myself that b1 needs to be a complex number, because I do not know a priori that the wave which will be reflected back will have the same phase as the coming one, the incident one. I do not know that, because it will depend on the properties of the reflection. So that is why for generality I have kept this, and without loss of any generality I have kept this real number. And that Pt again I can write as as A2 e raised to j omega t minus k2x, right? And what about that A2? A2 should also be kept as a complex number, because we do not know whatever wave gets transmitted that will have any phase with respect to this or not. We do not know. So that is why for generality we kept that. And what about wave coming from that side? There will be none, because that goes to actually infinity. From that point onwards it goes to infinity. So no wave comes back from that side. So this is the situation. So our job now is to figure out this and this in terms of this, because in terms of this, when I say also as functions of rho1 c1 rho2 c2, based on them, those properties, the reflection will happen and transmission will happen. So that is the idea. So what you should do is you have to apply a boundary condition at which things are actually happening, things are getting changed if they are. So what sort of boundary condition? The thing is, the pressure on this side, on the region 1, should be equal to the pressure on that side. There has to be balance of pressure. That is first condition. And the particle velocity also be same, continuous. There cannot be two different particle velocities, right? Because displacement, if they are different, then there will be a gap between those two regions. That never happens. So that is why the particle velocities also will be same. So these are the two conditions which we will use to evaluate these unknowns. Okay. Now what will give you the first equation, what it will give you? Now let us say our coordinate system starts from here only, and here, so x starts from here, so x is 0 there. So just put x 0 there, and what is the pressure on the left side? P1 I will say, so that will be equal to A1 e raised to j omega t plus B1 e raised to j omega t. You didn't ask a question, so I'll ask that. Suddenly I remember that. Why did I change K2 and K1, and why not omega? Means when the wave got transferred, why I am not changing something? Okay. So what I was asking is, that I said that it's K1, it's K2, it's C1, it's C2, and I kept omega constant. Why didn't I do omega 1, omega 2?
C1 and C2, so since K depends on C.
Yeah, means that you're saying that K changes because C1, C2 are changing, but I see there is a relationship, right? K is omega over C. Now I could have changed any two to keep the other constant. Why are you forcing me to keep this constant and change these two? Why? Means I could have said that you are saying that frequency remains same in both the case. I will say that K remains same in both the case. Means why would I mean? You should convince me that yeah, omega will remain same in both the case. Means why are you saying that? Why are you insisting on saying that wave number cannot remain constant? Wavelength will change. You are saying that. For example, in light also, when it gets into the other medium, you are saying that wavelength will change, not the frequency. But why? The thing is that will lead to sort of accumulation of energy. See this means I explained this way to my kid, so I am telling this. Suppose there is a pizza station here and there is a house here, okay, and there are two delivery organizations who deliver the thing from here to here. I mean they combinedly shift it. Now suppose every 10 minutes a pizza is getting out of the shop. Now this guy is having a bicycle, okay. Now so he takes that pizza by the cycle and returns back and gets the other pizza. So that means every 10 minutes he has to come back like that if the same person has to take it, and he has to hand it over to the other person and think that this guy is having a motorcycle, okay. That means in that, and then this guy knows that this guy will come back in another 10 minutes. So in that 10 minutes this guy can drive a long distance in the motorcycle and come back. So just think that this station, suppose this distance is x, and that distance covered by that motorcycle guy can be much bigger as compared to them, but if they have to be in sync, he has to come back by traveling that much distance so that it will be a sync there. Otherwise, if he comes back from a shorter distance, no, he will come but pizza won't be there. If he goes longer distance than the actual distance which is required, he won't come back and this guy will be waiting there with the pizza. So pizzas will be stacked there. In one case pizzas will be stacked, in the other case there will be no pizza. In one case this guy has to wait, in the other case that guy has to wait, but that cannot happen. So they have to travel in such a way, that distance, so that they will exactly be in sync at that location. That is, and those lengths are actually like the wavelengths, because the C's are different in different mediums. they depend only on, if you remember, the material properties, right? The pressure, suppose it's a gas, so the pressure and the gamma, है ना, gamma P by rho, pressure, density and gamma, based on that C is fixed. So like the way you said motorcycle is there, अब क्या करेगा वो, means he has a motorcycle, C is fixed for them, they can't control their C's. This guy also has his C, bicycle. But then what can, and then, so that is why the frequency has to be maintained, otherwise pizzas will be stacked there. So the only thing which can be changed is the distance that they have to travel. Somehow they have to move that distance and come back so that they will be in sync. And that is why this gets adjusted and this is kept constant. Otherwise energy will be stacked or lagged. Okay. So that's why, in fact, in while things get transmitted, wavelengths change, the frequency remains same. Okay. Means a particular, and that is why you call a red light from its frequency, that this is red because this has got this frequency in this, it will become red, it will be red only with a different lambda but with the same frequency. Okay, because the energy is getting bombarded at that frequency. There the only thing which will happen is the wavelength will increase. Okay. So that's one point. So that is why we are keeping the omega constant in both the places. Only change happening is K1 and K2 because C1 is C2 are different. And the pressure which will be on the left hand side of this line will be this, and the right hand side will be P2, which will be equal to A2. So here I should put this e raised to j omega t. Right, this is the boundary condition. Now, so that means e raised to j omega t, if you just cancel out, you have got A1 plus B1 is equal to A2. This is the one condition which must be satisfied. Then what? What about the other boundary condition, that the velocity must also remain the same? We are saying that u1 or I'll say incident. There, what did I say? What did I write? So this is, I should have also written this for completeness. Pi plus PR. This is PR, okay. So you see here, that's a very subtle thing which many students miss. Wave is coming and the wave is reflecting back. So at that location, both the pressures are there, which is coming in and which is going out. In fact, that is true for all locations. At any location, if you want to calculate the pressure, it has to be Pi plus PR, any point the pressure. And then that is what we did at that location when x is equal to 0. So this basically, this part we evaluated at x is equal to 0. So the pressure at any point on the left hand region is incident plus reflected back. And one more thing, students generally tend to think in terms of time domain. What I mean by that is they get stuck in this loop saying that, okay, I started this wave, when it's coming there, PR is not there, it should be only Pi, no? It hasn't even touched this plane, so it has Pi, and then when it gets reflected back, then in some zones up to this point it has come back, so it is Pi plus Pr, but at this point it is Pi only because it is coming only. Are you seeing that? So that confusion is quite valid, isn't it, or not valid? If not valid, then why not valid? Because in one of the seminars, one faculty asked this question, means you are applying this boundary condition at what time? You didn't tell anything about time and you are just applying this. So what is the answer? What should be the answer? See that thought process. Yeah. The way I now pose the question, I was thinking in terms of time domain. That means I was moving with time very slowly. But the equations which we have written now, all these things are written in frequency domain. That means when we wrote this, wherever I wrote it, this tells you that for a long time that piston has been oscillating like that sinusoidally, and the wave has been established completely, and then in the steady state we are seeing this. The steady state has already reached. We are not in the process of initiating this wave. Whenever we have written this, that means that thing has already been done. That is very important to realize. Okay. Otherwise, such questions will just make you feel jittery. So now, in this case, what has happened is, the way I described, actually it happened. For some time only this incident wave was there, for some time even only this pressure wave was there up to this point, but that phase, that time has gone. We have waited for a long time, almost like 1 year maybe, and then we are looking at it. Now everything has settled, and now that thing of something happening there has been inbuilt into the phase information of this in a long time situation. Okay. In long time, when you see, that is called the steady state, all these things happen, and after, if you now can see the waves individually, you can actually see one wave coming from this side and one wave going from that side, if you can actually see them. And the pressure which actually exists at a point, if you put a microphone there, you cannot measure Pi or PR. You cannot. There is no way you can measure. You will measure Pi plus PR. Okay. And that is why, in fact, by just putting a single microphone, you cannot tell this coefficient, because you will have, this will have two information. One is how much amplitude has reduced or increased, and how much phase has been included. So there are two unknowns there. So at least you will require two microphones to be put. If you can pick from two microphones, then you can solve for these things, both the phase and the amplitude variation. So that is where the concept of steady state and the transient thing comes into picture, and you should be completely clear about that if somebody asks you that question. Okay, these equations are in frequency domain. Steady state has been reached. Okay. Now, so this is one of the equation, and the other equation I was going to tell about is this. ui plus ur. So now again these are also the complex velocities. So this is on the left side should be equal to ut on the right side, and everything at x is equal to 0. Okay. Now for progressive waves we know the relationship, right? So between pressure and the velocities. So here I can write that this is pi over rho 1 c1 then minus pr over rho 1 c1. Okay, and in fact, yeah, so then that will be equal to pt by rho 2 c2. Now this minus, because moving backward, so here I think we had developed something. This, oh yeah. Okay, yeah. So this relationship, see the plus one and the minus one. So there is a minus sign between them. You see this? So that minus sign is playing that role there. Okay. Now, so then at x is equal to 0, if you write, you can simply put that cancelling out e raised to j omega t. You can simply write that, you know, finally that rho 1 c1 minus this is p, it's b1 by rho 1 c1 is equal to a2 rho 2 c2. Okay. Now this is another condition. Okay. That means now suppose you want to have the relationship between b1 and a1, you just have to eliminate a2. So okay, and solve for b1, and if you do that you will get, I am just writing it down, rho 2 c2 minus rho 1 c1 over rho 2 c2 plus rho 1 c1 times a1. Okay. So that is what you will get if you eliminate a2 from both the equations. Any observations which you want to make? Yep. So though we had assumed it to be complex, it turned out to be real. So we didn't know at that time that it will come out to be real, but now we know that it's real. Okay. And what does it tell you that it is real means what? That means the phase between A1 and B1 is nothing, 0. There is no phase between them. Okay. And if you calculate A2, so you will get, like, you know, A2 is 2 rho 2 C2 over rho 1 C1 plus rho 2 C2 times A1. Okay. So this also will come out to be a real number. And then so these are in terms of the pressure. So now you see that you know everything. If I come here, where did I do that? I came back a lot of one. Yeah. So that means I know this wave completely. I know this wave completely. I know this wave completely in terms of rho 1 C1, rho 2 C2 and A1. So if I incident some particular amplitude, how the how the amplitude will be of the reflected and the transmitted wave. Okay. Then you can actually calculate what the intensities. So incident waves intensity will be what? A1 squared over 2 rho 1 C1. Similarly, I reflected will be A reflected squared by 2 rho 1 C1, and I transmitted will be A transmitted squared by 2 rho 2 C2, and this was, this is equal to B1 squared, this is equal to A2 squared, the way we calculated. Okay. Now if you put them there and define alpha reflection, that is reflection coefficient, okay, energy reflection coefficient, you will get B1 squared over A1 squared, which will be rho 2 C2 minus rho 1 C1 squared over rho 2 C2 plus rho 1 C1 squared. Okay. And similarly, you can say transmission coefficient to be equal to I transmitted by I incident is equal to 4 rho 1 C1 rho 2 C2 divided by rho 2 C2 plus rho 1 C1 squared. Okay. So we will stop here for today, and what you do, you go through these equations and try to investigate them. When I say investigate, I mean you have to visualize, if I am coming from say a very thin medium to a thick medium, where rho 1 C1 is less in one medium and the other one it's more, what happens, and their relative values. If there is a huge difference, what happens? If there is almost no difference, what happens? So like that you try to investigate them, and we will start our discussion next class from that point. Okay. If you want, you can plot some curves to discuss that also. That would be actually good. Means from that you should also analyze, for example, if somebody shouts, suppose you are swimming inside a swimming pool, you are inside water, somebody outside shouting, will you be able to hear it? If not, then why? How many dBs it will be less? So now you should be able to, you have got all the equipment with you to calculate in terms of dBs also. So try to get some idea about feeling about what is the dB reduction when somebody shouts from outside to inside or inside to outside. Will that be different? If somebody shouts from water, will somebody else who is in air, will he be able to listen to it? So evaluate those differences. Means what will be the dB value reduction in this transmission. So these are coefficients. What I am trying you to evaluate is evaluate the dB difference, okay, by considering air and water, because rho c for air is almost like 400, okay, but rho c for water is huge, because c in water is almost like 1500 meter per second and rho is 1000. So it's a huge number. Rho 2 C2 for water is huge number as compared to rho 1 C1 for air, which is 400. So do that thing, try to see what you are getting, and we will see and discuss in the next segment.